Let's take a piece of DNA and let's just unwind it into its two strands and just help us remember that DNA is really a very, very long molecule. I'm going to put arrows here on our two strands of DNA. And the question I want to ask you is, if we were to replicate this DNA, what would the end result look like? So I'm kind of skipping over the entire process of how the DNA is replicated and focusing just on the product. And so we have three choices. The first is conservative replication. And in conservative replication, we have our old pair of DNA, and then we synthesize a completely new pair of DNA. So you can see the old pair that looks just the same as what we had before in yellow, and then we have a completely new pair, which is represented in blue. Our next choice is dispersive replication. And in dispersive replication, we're going to end up with two pairs of DNA. And in each one of those pairs, we have some old DNA and new DNA dispersed within that double-stranded DNA. So you can see there's yellow and blue mixed up together. And it wouldn't necessarily have to be in the ratio that I drew it in. I drew it in this kind of neat ratio where the yellow and blues are the same size, but perhaps the yellows would be a little bit bigger and maybe some of the blue parts smaller, or vice versa. And the third option we have is semi-conservative replication. And in semi-conservative replication, each pair has one old strand that you see in yellow, of course, and one new strand that's in blue. And this question was answered by two scientists, one by the name of Meselson and one by the name of Stahl. And they conducted a famous experiment which was named after them. So the Meselson-Stahl experiment. And in this experiment, they proved that DNA replication is semi-conservative. So this is how DNA is replicated.